My name's Rich Bayliss. I'm a systems engineer based in Sydney, Australia. If you kind of put together what we've been talking about today, we've been talking about the low-hanging fruit, the things that you should already be doing, right? And from Arista's perspective, that means, using merchant silicon to lower costs. It means moving away from modular systems. In carrier space, we've always liked those big hunks of metal, but using those pizza boxes, those 1RU systems, they're cheaper, they've got higher capacity than your existing modular systems, and they get you to 100 gig or 400 gig faster. And then finally, we've talked about converging the core with something like SRMPLS and converging the edge with services services control plane like EVPN. So there's lots of different things that we should already be thinking about, but then you get to the natural challenge. So hopefully, some of this resonates. Certainly not a wonderful experience, but if you look at when we talk about carrier automation, the sorts of challenges that we face are around dealing with OSS and systems complexity, getting through the fact that it's a multi-vendor network and there's already brownfield things in there with 30 years worth of protocols. And sometimes, as network engineers, we're our own worst enemies because we love those geek knobs. We want to be able to tune and tweak and play around with the configuration to get to exactly what we want. Now, there's different flavors of technology. I think over this NFD SP1, there's been a bunch of different vendors talking about similar technologies, but they have different flavors of how they'd like to see that implemented, and that complicates the ability for us to move forward with a single way of abstracting the network, a single way of abstracting services. And then on top of that, you've got dealing with configuration coming from multiple different sources, different controllers, different protocols, base configuration, security policies, and the like. On top of this, we have things like regulatory requirements, so we have to be able to get things under budget. And at the end of the day, who has time to do all of this, get something new into the network while dealing with all these challenges? And so the high cost of change in carrier networking absolutely favors status quo technology choices and absolutely status quo operational processes. And so it's really important for us at Arista to talk about how we help move towards a more optimized infrastructure as code approach, which enables us to bring in these new technologies and new protocols. So the first point that I wanted to make is that we need to avoid mystery box magic, right? So, every vendor will say, hey, we've got this new idea or this new solution. But at the end of the day, you have your unique requirements as a service provider, and they will feed into your particular process. The notion of dare I say, a God box for automation that's going to solve those problems and spit out, multi-vendor generic configuration items that abstracts away the complexity of what you're doing. I think we have to acknowledge the fact that that generic device configuration, while it might save some of the operational complexity of creating configuration, it results in generic outcomes and it removes your operational flexibility, right? So how do you deal with rolling out new features that appear within that vendor's operating system? You have to wait for that mystery box to be able to configure those new capabilities. Or what happens if there's an outage and you need to go into CLI and start to troubleshoot certain things? Maybe that requires a design around or a change in how you're actually applying configuration. That means now you're doing that workload manually until that mystery box actually takes into consideration the new way that you have to deploy while you work out how to either work around or design around or deal with a security issue. So there's a lot of promise in terms of automation, but having it as a mystery box in your workflow that's going to spit out configuration in the nirvana of a multi-vendor environment is something that we just need to keep our cynicism with us. And generally, carrier engineers are pretty cynical too.
What you're saying there, would you assert that it's not really possible to have abstracted services in your automation that, are not vendor specific? And then, you have your automation system that you say, I want a service that does X, Y, Z, and it spits it out to the various vendor devices. Is that what you're saying is not possible?
What I'm saying is you need to be involved in that process. Like you need to be able to say, let's say I have a Cisco environment and an Arista environment. I need to be able to make sure that if I need to make a change in how the Cisco configuration or how the Arista configuration is going to be generated, I don't have to then wait for like an upstream vendor that's providing me this automation to build that into their tool for me to be able to take consideration of it. And so essentially, if you look at this slide here, the industry has spent more than a decade talking about the transport method. And we see in the RFPs that we deal with, carriers are still asking for it. They want NetConf, they want RESTconf, they want OpenConfig. And each of these things have their own strengths and weaknesses, but all of those become mandatory requirements. Now, the how that we transport, the models or the configuration or the operational commands to the device, that's been well understood. But what I'm saying is the config definition or generating configuration is still an essential part of how you create value and how you create services. In the same way, infrastructure as code, no software developer is going to abstract the code to the point that they don't actually look at the code that comes out of like an SDK. They want to be in control of the actual final code so they can tweak it. So as we move away from CLI, we're going to move away from like physically typing into every single box, but we're not moving away from configuration, and we need to be able to take control of that configuration. Does that answer your question?
Yeah, I think so.
Yeah. So definitely we can do things in a multi-vendor environment. Yes, definitely we can do some degree of abstraction, but we have to be able to reach into that process and be able to deal with that ourselves. So some fundamental truths. Simplification is required to get, to permit greater levels of automation. After 30 years though of doing carrier features, there's a lot of snowflake design patterns out of there. And that's why we're suggesting, we can draw a line under SRMPLS, we can draw a line under EVPN and use those as targets for how we're going to simplify the network. Carriers can't outsource the design to an abstraction layer and remain competitive. If you're relying on a widget that creates generic configuration that other carriers are also going to use, and then your services have to compete with their services in the marketplace, you're going to end up with the same services, which means that you're not going to be differentiated. You're going to have to find a different way to compete, and that means you're competing on price. And so automation itself can't exist as a black box process or a mystery box process. Thirdly, we want to be able to deal with code, right? So if we're producing code, that means configuration. So we still have to take responsibility for the configuration as it flows through those workflows. And then finally, long-standing processes really need to evolve, but they have to do it in a safe and predictable manner. And I think this is the hardest part, working with carriers, and they've always done certain things. For instance, we always do authorization of every single CLI command. Now, if we're using an automated workflow, we still need RBAC and control over who can do what, but we don't need to enforce it at the device level because it's already coming over a secure protocol to the device itself. And we're burning cycles on the device, validating code that's actually being produced by a system that may have pre and post validation checks as well. So essentially what we need is that the process itself can evolve. So finally, what we're going to talk about today, and Carl in Canada has a demo. So this is a true spirit of the Commonwealth. And what we're going to talk about is an operational playbook based on Ansible. And the way that we're going to show that is that that's an open and a modern automation framework with a common language that you can use in a multi-vendor environment. And that's a CI/CD process that also enables that pre-validation and post-validation. And most importantly, it's another SDN. It's a way of creating self-documenting networking, right? So when you use these tools, they actually document what you've created and configured in the network, which is another thing which has always been terrible in carrier space. So the goals of today's demos, we're going to show how we define nodes and roles and automatically build the simplified underlay. We're going to extend services into that. But we're going to talk about how Arista's AVD or Arista's validated designs enable us to address some carrier use cases. So Carl, I'm going to hand over to you, and please take it away.
Okay, perfect. So my name's Carl Buckman. I'm a systems engineer based in Ottawa, Canada, and I'm going to talk to you about how we're extending that framework, which started as a framework to support primarily our data center use cases, but how we're extending that framework to now cover service provider topologies. So when we look at Arista AVD, which is an Ansible collection, one of its fundamental components is a fabric logic and an open source templating language. So we use Ansible very differently than other vendors. We build our own modules and roles to support Arista. And essentially we focus on simplifying and providing a fabric logic to treat the network as one element, as opposed to doing kind of box by box automation driven by Ansible. We look at building this fabric concept, and I'm going to dive into that in the next slide. And really what we try to provide is a simplified data model that abstracts some of the complexity of provisioning the topology the various services. And Ansible as a tool helps us bring us together this information from various sources. And this demonstration today, I'm going to focus on using YAML as my source of truth, my source of input stored in the Git repository. But Ansible, as you know, is open, and I can tie in other systems, and I can pull in information from tools like Nautobot, from our CloudVision, from an IPAM system, or other areas where I have my system of record for a particular piece of data. And then Ansible, yes, go ahead.
Hey, before you go into things on the demo side, from an Ansible standpoint, are you going to go into the demo showing both addition of services and removal as well?
I can certainly add them and then remove them after the fact. Absolutely. So, and that's a great question, and I can certainly demonstrate that. When we look at Ansible, really so we pull in the data, we aggregate the data, we transform the data into our configuration, and then we use we can go directly to the device, which is what I'm going to use today to speed up the demo due to the time, or go through CloudVision as the provision engine. And the beauty of using it with CloudVision, and 90% of our customers that use the Arista AVD collection that I'm involved in, and there's about 70 customers worldwide now, they like CloudVision as it's a safety net. I'm pushing to CloudVision, I stage it, I go through a change control management in CloudVision. I have a lot more robust telemetry in CloudVision to see how I'm interacting with my device. So in terms of the Arista AVD framework, and it's really an extensible automation framework, and this is what Rich was talking about. You need a framework that allows the customers, that is open, and that allows the customers to integrate or add their own custom templates. And let's take a look at the ground up of how we build this. So first of all, Arista EOS, single OS, and we interact with EOS using eAPI in this case. And we use actually the config replace methodology. So actually generate the CLI text-based configuration that we're used to, and we push down to that device using a config replace. So this allows us to have simplified templating logic to add, remove services or configuration. And then we have a design neutral abstraction layer that we refer to as EOS CLI config gen, which takes input data models in YAML or JSON format. And then we have, and this is where a lot of the, intelligence of the model is our fabric abstraction. So we have abstractions for our topology, our various network services, various common settings that simplify how I'm inputting. And it's really important. Today, I'm going to demonstrate sort of how I'm interacting with that natively, but our customers typically have a higher level of abstraction of how they provision that service via form-based. Okay, I need to provision new VPWS service. I'm going to go into a form, enter some fields, and then it's going to, create the data that's consumed by our EOS design fabric abstraction layer. So the demonstration that I'm going to do today is that we have a physical lab topology here. We have some P routers in the middle. They also act as route reflectors in this topology. I have 4 different PEs, and I have CPE devices that connect into my PE1 and PE4 router. And we're going to go ahead and reconfigure some of the underlay configuration, and also configure some services. And then after the fact, I'm going to unconfigure the services to answer Chris's question. Okay, so the first demonstration that I'm going to do is when we interact with AVD, when I'm defining my topology, my nodes, I'm able to, categorize them. So in this case, I'm looking at my various PE nodes. I have various defaults here, and then I start defining my nodes and, some filters that they have on. The ID is what I derive a lot of my IP address configuration on. And as I'm going through this, I'm noticing, I have a typo on my ID for PE3. I should be really doing this as ID3 because it's my 3rd node, and that's what I want to do. So I'm going to go ahead and regenerate and deploy my configuration to this node. and also impact. And you'll see that when I'm running this playbook, I'm not going to only impact, the PE node 3, but I'm going to impact other nodes that have relationships with that node and the configurations that I'm changing. So in this case, as I'm building this, I can see the configuration being generated. I'm not only generating config, I'm actually generating configuration documentation as well. So if I look at the change, and let's look at the diff on this. So on the node that I changed the ID, I can see what the ID influences. It influences my loopback and influence my node segment IPv4 index, which needs to be unique in a ISISR topology. My router ID gets updated. So a lot of different components get impacted just by changing this ID. And then I've pushed this to all of my device, and I grabbed a backup of my configuration. So in this case, actually to show Chris' question, I actually unconfigured some neighbors and reconfigured some neighbors on the device. All right, and this is the beauty of config replace, is I'm still, as a network engineer, I'm still working with a text-based configuration that I'm very used to. So when I'm looking at the changes that I'm pushing, I'm not looking at an XML or OpenConfig Yang document that I'm not familiar with. I'm working with the configuration that I'm familiar with. And then next, I'm going to make sure, so I've done this change, I'm going to validate and make sure that these changes are working. So I'm going to run my validation playbook. So this is more of a pre and post validation playbook that runs live on my environment. And it does a variety of tests. I'm going to, ping my loopback interface, ensure reachability, make sure my LLDP topology is accurate. And then I'm doing some EUS commands, getting some information, and then using Ansible asserts to verify that this is working correctly. So while this is running, I'm going to push this up. So I said, update underlay. And if you look at this live on the repository, you'll see these changes. I'm going to push them up to the public GitHub repository. So you'll see the commits, and you can actually look at the change that I've done and some of the documentation that got updated alongside it. So while this is still running, let's take a look at the documentation that gets created over here. So if I look at the documentation, if I look at the device, I can see I updated the underlay. So let's look at PE3, and I can see the documentation that AVD also provides. I can see that it also updated my P nodes, right? I showed this, that it updated my router neighbor configuration. So let's take a look at that in the documentation. So if I go to, my BGP configuration here, I can see my table has got up to date as well with this information. So the next step is I'm going to demonstrate service provisioning. So before I configure a service, I'm just going to run a quick playbook that will show that the services are currently not active. So I just wrote something really quick that does some show commands and displays us, the current state. So right now I can see I have no pseudo wire. I'm looking at the current VRF. There's no routing in the routing table. And then I'm going to do, these are tests on the CPE that I would normally not have access to as a service provider, but because we're in a demo environment, I can test from the customer side. I'm doing a simple ping across the topology, and right now my certs are failing and my pings are failing, so I have 100% packet loss. So I'm going to go ahead and now we have a simplified definition of how I create my services, and in this case, it's tenant-based. So I'm going to go ahead and actually start the deployment, and I'm going to run you through kind of how we define these services. So in this case, we have a layer 1 service, so that's a pseudo wire. I can define, the IDs that I want to assign, the nodes that this pseudo wire exists the interfaces that I want these defined. And when I read, this data model, I read that, ID 52 gets deployed to PE1 on Ethernet 5 and it's a subinterface.10, and then ID 513 PE4 and 310. And then we also provision a layer 3 EVPN service. So in this case, I define my layer 3 interface. Again, very simplified constructs of how I define that service. I hide all of the kind of underlying complexity of provisioning that service. And in this case, I provisioned a layer 3 VPN service to PE1 and PE4, so it's the same routers, and also BGP peering with the my CE device on the, and in this case, CPE1 and CPE2. So I'm going to go ahead and kick off the validation for that. So I'm going to validate my service and see, have these been provisioned correctly. While this runs, let's take a look at the first kind of outputs that we'll get from these. So now I can see I have, and all of this data, I'm just printing out screen. It's in JSON format. I could create assert statements to actually evaluate this data and ensure that I'm up and running. So now I can see I have my pseudo wires running. I have, I have routes that I can see. And same thing here, I see that I have a peering established with my CPE device. And now let's take a look at the, see if I'm finished. So all of my asserts now, my Ansible playbook with the pings, everything is successful. So if we look under the hood of these services of what we've provisioned, and again, let me take a look at this. If I look at PE4, we can see kind of with the data model input I have, it abstracted a lot of these additional, configuration knowledge of the specific operating system that we're working with, and simplified it for the input for either a user directly or for an upstream system where I would have a form-based type of input. And to finalize this demo and answer a quick question, let's go ahead and I'll unconfigure one of those services and see what happens. So let's say I'm going to unconfigure the L3 service. So I'm going to comment it back, and let's run the deploy again. And then I'm going to run the testing, and what we should see is that my ping for all my pseudo wires succeeds, but of course I've unconfigured the VPN service, so that will get removed. And then we can look at the backup configurations, right before the push. Let's see the delta that we have, if I catch it in time. So we'll see some of these interfaces disappear once I back up the configuration. Any questions so far as I'm going through this?
Yeah, hey, Chris here again. Thanks for showing the deletion. That's really, really cool. I'm a big fan of config replace when you're using Ansible, so I'm glad to see y'all doing the demo of that. Does Arista have anything in more of a services orchestration kind of side of things? So, one thing that I kind of think when I see this demo is I go, okay, well, you're still having to define things like the MTU. You're still having to define things like the IP addresses, and you still need a network engineer to do that. And one thing that I've seen the industry moving towards is, well, we don't want our engineers having to do that. We want them designing a service, and then we want, maybe somebody in the NOC just pressing a button that deploys a service, because we, in the service provider, we have large scale, cookie cutter stuff. A layer 3 VPN looks like a layer 3 VPN. Maybe there's a few, dials that get turned here and there. And this isn't something that I feel like you could throw to somebody who works maybe in a network operations center as like a tier 1 kind of engineer. So how would Arista address something that's more service model based? So where you're actually saying, hey, I have a customer and I want to deploy a layer 3 VPN, but I don't want to have to actually configure all that. I just want to say I need a layer 3 VPN between these folks.
Correct. So And this is where the business service abstraction comes in. And this is, we enable, I believe, with this model where some of the fabric abstraction, and right now we're interacting with models that frankly are still under development. I'm using a fork of Ansible AVD, and the work that we're doing right now to add the MPLS ISIS use case into it. But you're able to either add to that abstraction by adding your custom templates, and we have a special action plugin under the hood that it's called YAML templates to facts that allow you to dynamically add templates kind of at runtime, so your own templates definition. So you can start by having potentially a more simplified abstraction layer than what we have. But most of what we see in the field and what we help customers is they'll use something like ServiceNow as a form-based input or Ansible Tower as a form-based input that feed into these models, because our models already simplify some of the constructs. As you saw, they generated a lot more configuration than the input was required. So that's our first goal, is to really, have, and it's always a compromise, right? As we add more knobs or remove knobs, like customers, out of the 70 customers I work with, mostly on the data center campus side with Arista AVD, they all have different, even though we're all building leaf and spine, EVPN, VXLAN fabrics, they all have their own special little unique requirements, right? And then what we've seen is the customers, they develop their own business logic that feed into our models. So whether they have strong teams that are comfortable working with a pure GitOps, YAML-based inputs and some scripts, to customers using something like Ansible Tower, Autobot as the input, and then we ingest that into our fabric models. But our goal is to make this open. And a key thing I want to bring up is the participation that we have from our community. So Arista AVD is a super active project. I'm looking at here, in the last month, we had 40 pull requests merged, many issues closed, many issues open across 11 authors. And those 11 authors, it's, the community, so our customers, and also Arista engineers. And, now we want to take this to the service provider world. And by adding these new use cases and support, we're hoping to also, welcome the service provider community into this framework as well.
And sorry, Carl, for cutting in, but Chris,
yeah,
just to really wrap that up, for the demo, what we were showing was the YAML was the starting point for the automation demo. However, no one's going to ask anyone to be writing YAML. That is certainly not the most efficient way to do it. You would have a workflow and a process that takes a standard template and creates the YAML through some form of GitLab or otherwise. So that would actually be an extension to the process that we showed today. But yeah, there would be a nice clean way of getting someone who doesn't understand YAML to be able to generate that.
Yeah, thank you for the clarification there. I do appreciate that. Another question is, in using the Arista Ansible libraries, would you have a real good way to do rollbacks in case you apply a config and it doesn't take, or it takes and you did something bad?
Yeah.
What's going to be approach?
Yeah, so as you saw, I was able to roll back some of my configuration of the, with config replace, it's very easy to roll back. I would say, like in a pure infrastructure as code natively with Ansible, I'd say it's a little bit trickier and harder. With Cloud Vision, this is where when you have change control and you have a rollback capability, and you can actually select, I only want to roll back these 2 nodes out of this change control or this specific change, and actually then create another change control when I do that methodology. So then Cloud Vision really simplifies, or the operation, and also that safety net with operators, which I unfortunately didn't have time to demonstrate today. And I'm really happy, would be happy to do, an offline demo with the full Cloud Vision that I do often for customers when the time is given.